7. Today we will discuss about the self-selective catalysis and enzyme catalysis and what are the characteristics of enzyme catalysis. Three things we will mostly deal with: what is self-selective catalysis, enzyme catalysis, and what are the characteristics of enzyme catalysis. So we will discuss these three things. So what is self-selective catalyst? First we will discuss what is self-selective catalysis. Self-selective catalysis. Self-selective catalysis. Self-selective catalysis. We will discuss what is self-selective catalysis. The catalytic reactions which depends upon the pore structure of the catalyst. The catalytic reaction which depends upon the pore structures of the catalyst and the size of the reactant and products molecule are called self-selective catalyst. So what is self-selective catalysis? The catalytic reactions which depends upon the pore structure of the catalyst. The catalytic reactions which depends upon the pore structure of the catalyst and size of the reactant and product molecules. The catalytic reactions which depends upon the pore structure of the catalyst and size of the reactant and product molecule. The catalytic reaction which depends upon the pore structure of the catalyst and size of the reactant and product molecules are called self-selective catalysis. So the catalytic reactions which depends upon the pore structure of the catalyst and size of the pore structure means holes, very simple small holes, that is pore structure. The catalytic reactions which depends upon the pore structure of the catalyst and size of the reactant and product molecules are called self-selective catalysis. Self-selective catalysis. Example: cracking or isomerization of hydrocarbons in the presence of zeolites. Zeolites is an example of self-selective catalysis. Self-selective catalysis. Self-selective self-selective catalysis. So look at So what is self-selective catalysis? The catalytic reactions which depends upon the core structure of the catalyst. जो catalytic reaction का the catalytic reaction जो depend करेगा पूरा core structure. What do you mean by core structure? Core structure means very small fine holes that are present in this catalyst. Suppose in case of filter candle, you will best example you will observe this contains the core structure through which the water filtrates. So the catalytic reactions which depends upon the core structure of the catalyst and size of the reactant and product molecules are called self-selective catalysis. Example, cracking or isomerization of hydrocarbons. When the hydrocarbon cracking, breaking, that is breaking of large molecule into small molecules. Breaking or cracking or isomerization of hydrocarbon in the presence of zeolites is an example of self-selective catalysis. Important example is zeolite. An important zeolite catalyst used in the petroleum industry. Another point, and an important zeolite catalyst used in the petroleum an important zeolite catalyst used in the petroleum industry is JSMI. An important zeolite catalyst used in the petroleum industry is JSM-5, which converts alcohol into gasoline. It converts alcohol into gasoline. That is refined petrol. We can say that gasoline, that is good quality petrol. So an important zeolite catalyst used in the petroleum industry is JSM-5. This is JSM-5 is used, an important zeolite catalyst used in the petroleum industry is JSM-5, and it converts alcohol into gasoline. Generally, it converts alcohol into gas. It converts alcohol directly. Alcohol is converted into gasoline by using zeolite catalyst in the petroleum industry. JSM-5 is an important catalyst and self-selective catalyst which is used to convert the alcohol directly into gasoline. Clear? Zeolites are microporous or aluminum silicates. What is zeolite? Zeolites are aluminum silicate in which zeolites are complex silicates in which the some of the Si4+ ions are replaced by aluminum 3+ ions. Aluminum 3+ ions. So zeolites are aluminosilicates. What are zeolites? Zeolites are aluminosilicates or zeolites are complex silicates. In which some of the Si4+ ions are replaced by aluminum 3+ ions. Clear? So another point I am writing. First write this point. Another point is that zeolites are are microporous and aluminum silicates. Zeolites are microporous and aluminum silicates. That is zeolites are complex silicate. That is zeolites are complex silicates. Zeolites are microporous and aluminum silicates. Zeolites are microporous and aluminum silicates. That is zeolites are complex silicates in which some of the Si4+ ions are replaced by aluminum 3+. In which some of the Si4+ ions are replaced by aluminum 3+ ions. So in place of aluminum 3+ ions, that will be replaced by some of the Si4+ ions are Si4+ ion को replace किए करियो aluminum 3+ ion. So zeolites are microporous and aluminum silicate. We can say that zeolites have microporous structure. Zeolites have microporous, very small holes are present, and aluminum silicates. Zeolites, we can say that zeolites are aluminum silicates. Zeolites are aluminum silicates. That is, zeolites are complex silicate. We will call the zeolites are complex silicate in which some of the Si4+ ions are replaced by aluminum 3+ ion. Here the Si4+ ions are replaced by aluminum 3+ ions. Here Si4+ ions are replaced by aluminum 3+ ion. So this is all about the self-selective catalyst. He will put the question, what is self-selective catalyst? Give one example. You can take it, the important zeolite catalyst used in the petroleum industry. Important zeolite catalyst used in this petroleum industry is JSM-5, and cracking or isomerization of hydrocarbons in the presence of zeolite is an example of cracking or isomerization of hydrocarbon in the presence of zeolites is an example of self-selective catalysis. So you can write only this part also. Suppose you will put self-selective catalyst, you will write the definition. What is the definition? The catalytic reaction which depends upon the pore structures of the catalyst and the size of the reactant and product molecules are called self-selective catalysis. So you will first जो catalytic reaction का depends upon the pore structure of the catalyst pore structure means very small fine holes that are present in the catalyst. The catalytic reaction which depends upon the pore structure of the catalyst and size of the reactant and product molecules are called self-selective catalysis. First only definition लिखियो आउ गोटे जदी एग्जांपल लिखिलो cracking or isomerization of hydrocarbons in the presence of zeolite. Cracking or isomerization of hydrocarbons in the presence of zeolite is an example of self-selective catalyst. Next, enzyme catalysis. This is all about self-selective catalysis. You may write this part, or these are the additional points which you may write or may not, but only 2 points you must have to write. First is definition. What is self-selective catalyst? The catalytic reaction which depends upon the pore structure of the catalyst and size of the reactant and product molecules are called self-selective catalyst. Example, cracking or isomerization of hydrocarbon in the presence of zeolite is an example of self-selective catalysis. Or an important zeolite catalyst used in the petroleum industry is JSM-5. Which converts alcohol directly into gasoline. Clear? Next is enzyme catalysis. Next is enzyme. Next is enzyme catalysis. Enzyme catalysis. Enzyme catalysis. What is enzyme catalysis? Enzymes are complex. What is enzyme catalysis? There are some good enzymes which are enzymes. Mostly vitamins are also called enzyme. Vitamins are also called enzymes also, because they are known as biochemical. They are also known as biochemical catalysis. Or actually, what enzymes are complex nitrogenous compounds. Enzymes are complex nitrogenous organic compounds produced by plants and animals. So what are enzymes? Enzymes are complex nitrogenous compounds produced by living plants and animals. Actually, all proteins, as you know that all proteins contain nitrogenous compounds. Proteins are nitrogenous compounds. Proteins are nitrogenous compounds. We are consuming nitrogen not directly but indirectly in the form of protein. We are consuming nitrogen not directly but indirectly in the form of protein. We are eating meat that contains also all animal proteins that contain nitrogen. So we are consuming nitrogen not directly but indirectly in the form of protein also. In the form of protein. So all proteinous substance, as we know that all proteinous substance contain nitrogen. So we are consuming nitrogen not directly but indirectly in the form of food also, because all proteins contain nitrogen. So what is, first we will discuss what is enzyme catalysis. What is enzyme catalysis? First point, enzymes are complex nitrogenous organic compounds which are produced by living plants, and animals. Enzymes are complex nitrogenous organic compounds which are produced by living plants and animals, and they are actually called protein. They are actually called protein molecules of high molecular mass. They are actually called protein molecules of high molecular mass. They are actually protein molecules of protein molecules of high molecular mass. They are actually protein molecules. They are actually protein molecules of high molecular mass and form colloidal solution. And form colloidal solution in water. Form colloidal solution in water. Actually, reactions catalyzed by enzymes the reactions which are catalyzed by enzyme included in heterogeneous catalysis. Reactions catalyzed by enzymes are included in heterogeneous catalysis. Reactions catalyzed by reactions catalyzed by enzymes are included in heterogeneous catalysis. Reactions catalyzed by enzymes are included in heterogeneous catalysis. Actually, those reactions which are catalyzed by enzymes, the reaction which is catalyzed by enzymes are included generally in heterogeneous catalysis. What is homogeneous catalysis and heterogeneous catalysis? We have already discussed previous classes. So homogeneous, if the catalyst and reactants are in same phase, that is homogeneous. If the catalyst and reactants are in different phase, that is heterogeneous. If the catalyst and reactants are in same phase, that is homogeneous catalysis. The catalysis is called homogeneous catalysis. If the catalyst and reactants are in different phase, that is heterogeneous catalysis. So one important point is that reactions catalyzed by enzymes are included in heterogeneous catalysis, and they are also known as biochemical catalysis. The enzymes, so enzyme catalysis is also called biochemical catalysis. They are called as biochemical. They are called as biochemical. They are called as biochemical catalysis. They are called as a number of reaction animal and plants. Actually, there are so many number of reactions which are catalyzed by enzymes. There are so many number of chemical reactions in plants and animals which occur due to enzymes, which occurs or which is catalyzed by enzymes. There are so many numbers of, there are a number of, we can say that a number of reactions which occur in plants and animals. A number of reactions which occur in plants and animals are catalyzed by a number of reactions which occur in plants and animals are catalyzed by enzyme. There are so many reactions which occurs in plants and animals are catalyzed by enzyme. So a number of reactions which occur in plants and animals are catalyzed by enzyme. So enzyme catalysis, they are called biochemical catalysis. So enzyme catalysis, the other name is called what? Biochemical catalysis. The other name is called what? Biochemical catalysis. Next we discuss what are the mechanism of enzyme catalysis reaction. That is lock and key theory. So next we will discuss what is the mechanism behind enzyme catalysis. What is the mechanism behind the enzyme catalysis? First is, enzymes are complex nitrogenous organic compounds which are produced by living plants and animals. This point will get very important thing. What is it? Enzymes are complex nitrogenous organic compounds which are produced by living plants and animals. Look at, enzymes are complex nitrogenous. All enzymes are complex nitrogenous compounds. As you know that they are actually protein molecules of high molecular mass. As we know that all proteins contain nitrogen. So we are consuming nitrogen not directly but indirectly in the form of protein. We are consuming nitrogen not directly but indirectly in the form of protein. Clear? we are consuming oxygen directly, that is by inhalation. Similarly, we are consuming nitrogen not directly but indirectly in the form of protein, because we are consuming everyday food or proteinous food, that suppose milk, or we can say that meat, fish, that animal, mostly animal proteins contain maximum nitrogen. So we are consuming proteins in the form of nitrogen. That is also, enzymes are actually protein molecules of high molecular mass. Enzymes, we can simply say that enzymes are complex nitrogenous organic compounds which are produced by living plants and animals, and actually enzymes contain proteins molecules of high molecular mass. Enzymes contain protein molecules of high molecular mass and form colloidal solution. Colloidal, next one is what is colloidal solution, and milk is the example of colloidal solution. So enzymes are included reactions which are catalyzed by enzyme. दो reaction का enzyme presence में होगा, enzyme will act as the catalyst, and generally that is heterogeneous catalysis. So reactions catalyzed by enzyme are included in heterogeneous catalysis. Reactions catalyzed by enzymes are included. Reactions catalyzed by enzymes are included in heterogeneous catalysis, and they are called biochemical catalysis. A number of reactions which occur in plants and animals are catalyzed by enzyme. Number of chemical reactions which occurs in plants and animals that are catalyzed by enzyme. So this is about enzyme catalysis. If you cannot write anything, simple fast part you write: enzymes are complex nitrogenous organic compounds which are produced by living plants and animals. Next is they are actually protein molecules of high molecular mass. What are the enzymes? They are actually protein molecules of high molecular mass and form colloidal solution in water. Reactions catalyzed by enzymes are included in heterogeneous catalysis. Reactions catalyzed by enzymes are included in heterogeneous catalysis. Next, so you will simple write 2 points, but more, it is not needed to write more. Simple, you may write this point: enzymes are complex nitrogenous organic compound. What is enzyme catalysis? Enzymes are complex nitrogenous organic compounds which are produced by living plants and animals. And then enzymes are complex nitrogenous organic compound जोटा में पाइबा को living plants और animal. तार molecular mass टा कौन आसिबो? High आसिबो. तार molecular mass टा high आसिबो, and that form colloidal solution. And they are called biochemical catalysis. These 2 points you may write or may not. It is up to you. So next is what are the mechanism behind. Next is the mechanism of enzyme catalysis. Mechanism of enzyme catalysis, lock and key theory. Mechanism of enzyme catalysis, lock and key theory. So in lock and key theory there are 2 things: step 1 and step 2. Step 1, in this step enzyme substrate complex is formed. Step 1, enzyme plus substrate mix to give enzyme substrate complex. Second step, enzyme substrate complex decomposes to give product and enzyme. Enzyme substrate complex decomposes to give product and enzyme. Clear? So first step 1. In this step, enzyme substrate complex is formed. In this step, enzyme substrate complex is formed. That is enzyme plus substrate that gives enzyme substrate complex. Enzyme plus substrate that gives enzyme substrate complex. Second step, step 2. In this step, enzyme substrate complex decomposes to give product and enzyme substrate complex decomposes to give enzyme and product. Look at ES gives enzyme plus product. So these are the two mechanisms of this reaction. Look at why this is given lock and key theory. I explain with the lock and key how this enzyme will act as key and the substrate will act as the lock. That we will discuss later. Look at first step. In this step, enzyme substrate, this is enzyme substrate complex. In this step, enzyme substrate complex is formed. In this step, enzyme substrate complex is formed. Enzyme plus substrate to give enzyme substrate complex. Second step, in this step, enzyme substrate complex decomposes to give product and enzyme substrate complex decomposes to give product and enzyme. Enzyme substrate complex decomposes to give product and enzyme. Enzyme substrate complex, this is enzyme substrate complex decomposes to give enzyme plus product. Enzyme plus product. Clear? So I will explain this thing. So two steps. These two steps. First step only enzyme mixed with substrate to give enzyme substrate complex. Second step enzyme substrate complex decomposes to give enzyme and product. Clear? Next, this thing I will explain with the lock and key theory. How this will be explained in looking at this. So two step only this reaction occur. So enzyme plus substrate that give enzyme substrate complex. Second step, enzyme substrate complex decomposes. Enzyme substrate complex decomposes to give product and enzyme. Product and enzyme. Look at this. Substrate. Substrate that is reactants. So you will look at this picture. Actually, this will attach with this. This is enzyme substrate complex is formed. This is enzyme substrate complex is formed. Clear? This is enzyme substrate complex is formed. How this is formed? Look at. enzyme, this will be this is enzyme, this is substrate. So this is enzyme, this is substrate. So this is lock and key theory. This is lock and key enzyme. This is enzyme substrate complex. 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 Either will be planning, so that will be either this thing. Either will be out here. That will be entropy. So enzyme substrate enzyme. This is enzyme plus substrate. Sorry, this is enzyme plus product. Product. Look at this is product. Product. This is product. This is enzyme. What is this? Is enzyme. Enzyme plus product. Look at it. So enzyme first step, enzyme plus substrate. Enzyme substrate this is enzyme substrate complex. So this is step 1. This is lock and key theory. So it is, I am not comfortable in drawing the diagram. I am trying not to understand this and draw this, but this is, you will observe this diagram from the book clearly. So enzyme is the catalyst, substrate is the reactant. Enzyme plus substrate mix to give enzyme substrate complex. This is step 1. In this step, enzyme substrate complex is formed. Enzyme mix with substrate to give enzyme substrate complex. This is step 1. Step 2, enzyme substrate complex decomposes to give enzyme plus product. Clear? This is the mechanism of enzyme substrate. This is the mechanism of enzyme catalysis. In advanced classes, you will read this Michelson-Menten catalysis. This is the mathematical equation which we will discuss in enzyme catalysis. Mechanism of enzyme catalysis. So this is the theoretical part. So two step. First step is enzyme plus substrate to give enzyme substrate complex. Second step, enzyme substrate complex to become enzyme substrate complex decomposes to give enzyme plus product. Clear? Next, some examples of enzyme catalyzed reaction. Some examples of enzyme catalyzed reaction. Some examples of enzyme catalyzed reaction. There are some examples of enzyme catalyzed reaction. And how would you was doing? Here, what is it? Should I do it? Eight of the can see got back. Eight hand to hand, hand for you. Next, some examples of enzyme catalyzed reaction. This reaction will give you the data of enzyme catalyzed reaction. So cane sugar C12O22O11, C12H22O11 cane sugar. You remember only this enzyme cane sugar plus water, in presence of invertase. Cane sugar plus water in presence of invertase, that gives glucose application. Thus, cane sugar plus water in presence of invertase, that gives glucose plus fructose. Look at cane sugar plus water in presence of invertase, that gives glucose fructose. Glucose plus fructose. Cane sugar plus water in presence of enzyme, that is invertase, that gives glucose plus fructose. Next, C6H12O6 in presence of zymes. C6H12O6 in presence of zymes, that gives 2C2H5OH plus 2CO2. C6H12O6 in presence of zymes, that gives ethyl alcohol plus carbon dioxide. That enzyme is what? Zymes enzyme that converts glucose to ethyl alcohol and carbon dioxide. Clear? So what is the enzyme? Zymes is the enzyme. Next is 2 starch. C6H10O5N. C6H10O5N plus NH2O in presence of diastase. In presence of diastase, that gives C12H22O11. C12H22O11, it is a maltose. Maltose in the presence of maltase enzyme. Maltose in the presence of enzyme maltase, that convert to glucose. Glucose is C6H12O6. So this is starch NH2O in presence of enzyme in presence of enzyme what? In presence of enzyme diastase, that gives maltose. Maltose in the presence of enzyme maltase, that converts to glucose. So starch plus water. This is glucose plus this is glucose in the presence of zymes enzyme, that converts ethyl alcohol to carbon dioxide, and cane sugar in presence of invertase, that converts to glucose plus fructose. Next, starch in presence of diastase convert maltose in the presence of enzyme maltase, that converts to glucose. So these are the only short questions. Which enzyme is used for the conversion of glucose to ethyl alcohol? Only answer is zymes. Which enzyme is used in the conversion of starch to maltose, diastase? Or which enzyme is used for conversion of maltose to glucose, maltase? So these are the only short question or 1 mark question he will put. Clear? Next is another 3 examples. Urea. What is the formula of urea? As you know that the formula of urea is The formula of urea is what? The formula of urea is what? NH2 CO NH2 plus water urea. Urea spelling UREAS. Urea it is over 2 NH3 plus CO2. 2 NH3 plus CO2. Urea that converts to ammonia plus carbon dioxide. Urea that converts to ammonia and carbon dioxide in the presence of enzyme urease. 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 Next is milk. Milk converted to curd. Milk converted to curd. Curd ala curd. Dahi. Ksiro converted to dahi in the presence of lactobacilli. Lactobacilli. Lacto-LACTO, lactobacilli, BACILLI, lactobacilli. Next, proteins converted to amino acids. Proteins converted to amino acids by trypsin. Proteins converted to amino acids by trypsin. TRYP. So trypsin. 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 Proteins converted to amino acids by trypsin. TRYPSIN. Milk converted to curd by, you will put the only one mark question. How, what is the enzyme used for the conversion of milk to curd? What is the enzyme? Lactobacillus. Proteins to amino acids, trypsin. Urea to ammonia, this is ammonia. Urea to ammonia by urease. Next is proteins to peptides. Proteins to peptides are proteins to peptide. Protein to peptides, pepsin. Proteins to peptides by pepsin. Proteins to peptides by pepsin and proteins to amino acids by trypsin. Milk to curd by lactobacilli. Urea to ammonia by urease. You will put the short question, 1 mark question, basing upon this example. What are the examples? You will put how, which enzyme is used for the conversion of urea to ammonia. Urea to ammonia, urease. Only you will write urease. One. Which enzyme is used for the conversion of milk to curd? Lactobacilli. Which enzyme is used for the conversion of proteins to amino acids? This occurs in stomach. In stomach, proteins converted to amino acids by trypsin. Proteins converted to peptides by pepsin. Very important examples I have already given. This data you will put. This is also 1 mark question is putting in medical exam also. These are the enzymes. What are the enzymes? You will mostly put 1 mark question to medical entrance also. So next is characteristics of. What are the characteristics of enzyme catalysis? Next, characteristics of enzyme catalysis. Characteristics of enzyme catalysis. What are the characteristics of enzyme catalysis? First one, high efficiency. enzymes. What are the characteristics of enzyme catalysis? Enzyme catalysis, one molecule of enzyme may transfer 1 million molecules of the reactant per minute. One molecule of enzyme may transfer one molecule of enzyme may transform 1 million. One molecule of enzyme may transform 1 million molecule of reactant per minute. One molecule of enzyme may transform 1 million molecule of reactant per minute. So, one molecule of enzyme will transform 1 million molecule of reactant per minute. So, what is you will predict what is the efficiency of enzyme? So, enzyme has high efficiency to transform 1 million. Simple. One molecule of enzyme, only one molecule of enzyme that transform 1 million molecule. 1 million means 10 lakh. 1 million molecules of reactant per minute in 1 minute. So, efficiency of enzyme is very high. This is the very important characteristic. Efficiency of enzyme is always very high. One molecule of enzyme may transfer 1 million molecules of the reactant per minute. So, we will predict that the efficiency of enzyme is very high, or enzymes are good catalyzed. Enzymes have good catalytic characteristics. Enzyme catalyst has very good efficiency of catalyzing the chemical reaction. Clear? Second, highly specific in nature. Second point, highly specific in nature. Highly specific in nature. Highly specific in nature. Each enzyme catalyze. Each enzyme cannot catalyze. Each enzyme cannot catalyze more than one reaction. Each enzyme cannot catalyze more than one reaction. Good reactions, synthesis, different enzymes are required for different. We can say that different enzymes are required. That is, we can say that different enzymes are required for different enzymes are required for different reactions. So we can say that each enzyme or one enzyme cannot catalyze more than one reaction. One enzyme will catalyze one reaction. So different enzymes are for different reaction. We require different enzymes. Different enzymes are required for different reaction. Different enzymes are required for different reaction. Clear? Different enzymes are required for different reactions. So enzymes characteristics of first is high efficiency. Second is highly specific in nature. Specific means different enzymes are required for different reaction. One enzyme cannot catalyze more than one reaction. One enzyme cannot catalyze more than one reaction. Only one enzyme can catalyze one reaction. So second, high efficiency. One molecule of enzyme may transfer 1 million molecule of reactant per minute. So how much here? You predict the efficiency of the enzyme catalysis. One molecule of enzyme can transfer 1 million molecules of reactant per minute. Next is third point, optimum temperature. What is optimum temperature? Next is Next is optimum temperature. Third one, optimum temperature. What is optimum temperature? The temperature at which efficiency of an enzyme is maximum. जो टेम्परेचर रे एंजाइम रो एफिशिएंसी मैक्सिमम हो जो टेम्परेचर रे एंजाइम रो द टेम्परेचर एट व्हिच एफिशिएंसी ऑफ द एंजाइम इज मैक्सिमम इज कॉल्ड ऑप्टिमम टेम्परेचर. द टेम्परेचर at which the temperature at which the temperature at which the efficiency of enzyme is maximum. The temperature at which the efficiency of enzyme is maximum is called optimum temperature. So the temperature at which the efficiency of enzyme is maximum. जो temperature enzyme efficiency का maximum होगा तब कौन होगा optimum temperature. The temperature at which efficiency of enzyme is maximum is called optimum temperature. जो temperature efficiency of enzyme का maximum होगा तब कौन होगा optimum temperature. Actually human body temperature that is 310 Kelvin. Human body temperature that is 310 Kelvin is the optimum temperature, and 37 degree centigrade or 310 Kelvin is the optimum temperature for human body. Human body temperature that is being at 310 Kelvin is suited for enzyme catalyzed. So 310 Kelvin is suited for enzyme catalyzed. Human body temperature is 37 degree centigrade or 310 Kelvin, which is suited for enzyme catalyzed reaction. Clear? So what is optimum temperature? The temperature at which efficiency of the enzyme is maximum. जो temperature enzyme का efficiency का maximum होगा तब कौन होगा optimum temperature. The temperature at which efficiency of the enzyme is maximum is called optimum. The temperature at which efficiency of the enzyme is maximum is called optimum temperature. Clear? Similarly, actually human body temperature that is 37 degree centigrade or 310 Kelvin, which is suited for enzyme catalyzed reaction. Human body temperature that is 37 degree centigrade or 310 Kelvin, which is suited for enzyme catalyzed reaction, and this is the optimum temperature. So optimum temperature is the temperature at which the efficiency of the enzyme is maximum. The temperature at which efficiency of the enzyme is maximum, that is called optimum temperature. So what is optimum temperature? The temperature at which efficiency of the enzyme is maximum is called optimum temperature. Similarly, third point, next fourth point, fourth point is optimum pH. Optimum pH. So what is pH? pH, as you know that pH is defined as the negative logarithm of hydrogen ion concentration. pH is defined as the negative logarithm of hydrogen ion concentration. The rate of an enzyme, the rate of an enzyme catalyzed reaction is maximum. The rate of an enzyme catalyzed reaction is maximum at optimum pH. The rate of an enzyme catalyzed reaction. The rate of an enzyme catalyzed reaction is the rate of an enzyme catalyzed reaction is maximum at optimum pH. The rate of an enzyme catalyzed reaction is maximum at optimum pH. The rate of an enzyme catalyzed reaction is maximum at optimum pH, whose range is 5 to 7. Whose range is 5 to 7. So enzyme catalyzed reaction, the efficiency of enzyme catalyzed reaction is maximum within the pH range 5 to 7. So this is the optimum pH. Optimum pH, similarly the pH at which efficiency of the enzyme is maximum. Like the optimum. So like the temperature, the pH at which the temperature at which efficiency of the enzyme is maximum is called optimum temperature. Similarly, the pH at which efficiency of the enzyme is maximum is called optimum pH. Next is coenzymes. Another two bits. Coenzymes. What is coenzymes? Coenzymes act as promoter. Coenzymes acts as promoter. Coenzymes act as promoter for enzyme catalysis. Coenzymes act as promoter for enzyme catalysis or catalyst. Coenzymes act as promoter for enzyme catalysis. So what is promoter? As you know that promoter is the substance which increases the efficiency. Promoter is a substance which increases the efficiency of catalyst, or simple, increase the efficiency of catalyst is called promoter, decrease the efficiency of catalyst is called anti-catalyst or catalytic poison. Similarly, here coenzymes will act as the promoter that increase the efficiency of enzyme catalysis. So coenzymes act as promoter for enzyme catalysis. Metal ions पूरा होगा 300 metal ions such as Mn plus, Mn2 plus, metal ions such as Na plus, Mn2 plus and cobalt 2 plus increases the metal ions such as Na plus, Mn2 plus, cobalt 2 plus increases the activity of the enzyme, so that will act as coenzyme which increases the efficiency of the enzyme. Metal ions such as Na plus, Mn2 plus, cobalt 2 plus increases the activity of the enzyme, so that will act as coenzyme. Last is effect of inhibition. Last bit, effect of inhibition. Last characteristics. कितना पढ़ना है इसका? D बने, D जो बेटा दे रहा हूँ. Effect of inhibition. मतलब B के और BI होते हैं, B की BI कहा जाएगा. Effect of inhibition. The compounds such as HCl, H2S, CO, and the ions such as Ag plus, Ag2 plus, which decrease or destroy the activity of enzyme. The compounds such as HCl, H2S, CO, and the ions such as Ag plus, and the ions such as Ag plus, Ag2 plus destroy etc. Destroy the activity of the enzyme. The compounds such as HCl, H2S and CO and the ions such as Ag plus and Hg2 plus destroy the activity of the enzyme. These are called inhibitors. These are called inhibitors which slow down the rate of the enzymatic reaction. Which slow down the rate of the enzymatic reaction. The compounds such as HCl, H2S and CO and the ions such as Ag plus and Ag2 plus destroy the activity of enzyme. A compound HCl, H2S, CO ions Ag plus Ag2 plus that will destroy the activity of enzyme in an enzyme catalyzed reaction. So this is called catalytic enzyme poison. So they will destroy the activity of enzyme. So these are called inhibitor. What is inhibitor? Inhibitor of the substance which slow down the rate of the enzymatic reaction. Inhibitors slow down the rate of the enzymatic reaction. Or these are called inhibitors which slow down the rate of the enzymatic reaction. Thank you. So these are all the characteristics of catalyst. Thank you. Next class we will discuss the colloids. Here.